Mistério.
Hi everyone, can you hear me? Okay, it's good. Okay, so let's start. My name is António Capelo, and like Marco said, I'm a front-end engineer at Moxie, and I'm here to talk about props per minute. And just before I start, a little bit against what João was talking about, and I agree totally with him. I'm going to talk about React, which is a library, how do you call it? So just so I get an idea, can I get a hands up? So to anybody that heard about React or is using React? 1, 2, 3, 4. Okay, some people. Okay, so for those that you don't know React, I'm sorry. I'm really sorry, but I think that most of the concepts that I will approach, they are somewhat translatable to other type of libraries, and I think that's it. Let me just warn you that there will be a lot of code, like in Joan's talk. So I'm sorry for that, but I promise to make worth your while. So the first thing that I want to talk about is, yeah, it's a funny GIF, right? Sorry if there are any jQuery developers in the house. So basically, I want to talk about a few React tips or tools or patterns, whatever you want to call it, that I think might be handy on our day-to-day usage. And I want to start to talk about context, and not context in the sense of what's happening up until now, but more like React context. React.js documentation states that the vast majority of applications do not need to use context. And it also says that if you want your applications to be stable, don't use context. It is an experimental API, and it's likely to break in future releases of React. This is also in the JS docs. However, you're probably using it if you're using React, okay? And I will come back to it later. But now I want to say, basically, React is all about, or all between commas, but is all about cascading state or props down to components, right? So let's imagine this scenario. We have a component A, which has a shared data variable that renders B, and B renders C, which in turn needs that shared data variable. We have this type of data dependency. And let's keep Redux out of our minds just for a bit. But basically, we have this type of pairing between them. And one type of solution, can you guys see the code more or less? Yeah, I can zoom in if you want, please shout. So what we can do is basically on shared component A, we have that shared data, which is a foobar object, and on its render function, we are just rendering B and passing that shared data as a property to component B. And then on B, we receive that property and pass it down to the component C, which is one of our children. And then on component C, it does whatever you want with it, but keep in mind that this may be repeated along the tree, right? So we don't know if we're going to have a more deeper tree, so this might happen more time. Another solution for this problem would be, let me zoom in, if we could change the component B source code, we could say that, okay, B accepts a children property, so we can basically, when rendering B, we can use B to wrap that component C. So in the scope of the component A, we have access to that property, and we don't have to pass it down the tree. Does it make sense? I think so. But this is not always possible, because sometimes we don't own all the code base, or even the structure of the HTML doesn't allow it. Yeah. So coming back to the context, the context lets us share data down to our app tree directly to specific nodes, not having to pass them along the way as props. So for this to work, we basically have to define a getChildContext method on our, let's call it provider or context provider component, using the getChildContext method. And in this scenario, we are just returning an object which is shared data with the current data value. And then we have like a consumer node that basically states which keys of the context he wants to listen to. So in our, you might think that must lead to spaghetti code, right? Probably. But we can use some tricks to make it less probable. And one of the tricks is a provider pattern. So a provider pattern lets abstract defining what's being shared into a React component. So in this scenario, what we do is we create a shared data provider that basically holds the data and has the single responsibility to inject that data as a context into the application. And we basically just wrap our application. In this case, the component A would be like our top level component. We wrap that component into that provider, and okay, we have the context injected, so we don't have to mess around with the getChild method, etc. And at the side of this, we have the higher order component part. So for those that you don't know, a higher order component is a function that basically receives a component and then returns or renders that same component, but injects some behavior or some properties into it. So this lets us reuse some component logic to consume that data from the context. In our scenario, we're basically creating a shared data HOC that receives a wrapped component and then returns that same wrapped component, injecting that shared data as a property. So it's cleaner this way. And on the component C, we just receive it as a property, given that we are exporting the component C using that shared data HOC. As I'm going to call it. So, does it make sense? You following it? Okay. Am I making you dizzy with all the zooming in, zooming out? No? Okay. Yeah, he is. Okay. Give that guy some water. Okay, so coming back to, you're probably using it without even knowing it. Who's using these patterns? The React router, which is one of the best known routing solutions for React applications, is using it. So on the left, we have the provider of the context of the router that's basically injecting a new context into our application. And then we have the also well-known with router HOC that basically does what the shared data HOC provider was doing. It's reading data from the context and injecting it as a property into our child component. So it's very similar, right? Also, React Redux, as we have been talking about. If we're using React Redux, normally what we do is we import the pattern provider from the React Redux package, and then we pass it a store after the create store method from the Redux package. So you're basically wrapping the whole app in this provider context. And also, we have the connect. Connect, it's nothing more like a normal HOC that basically accepts functions as mapping mechanisms. So these patterns are all over the place, and even though it's an unstable API, we're using them in our libraries. And there's many more, right? So these HOCs, they have some problems, okay? One of the problems is they cause indirection, because we may wonder which HOC provides which props. If we were the ones that wrote it, it's fine. We already know that with shared data HOC, it's injecting in the property shared data. But if we are basically inheriting from someone or using a library, we are always a bit unsure of what's happening on the background. Also, they have naming collision problems. Because two HOCs that use the same property name will basically collide and overwrite each other, and only the later one will persist. And React won't warn us about it. This normally happens if you basically use some library or some function that composes HOCs and basically creates an answer. You may mess up in the middle of it, and you don't get a warning. So it's a big problem. And finally, there's only statically composable. Okay, so with this pattern, composition only happens once when the component class is created, and we can't decide at runtime which type of HOC or which strategy we want to use. If we want to do that, we have to create another level of abstraction, create new HOCs that inject new props, depending on, so you get the point. So it's kind of dangerous. So we have a new pattern that's becoming more and more famous, which is the render props pattern, or the function as child pattern. And it's very simple, because it's just passing a property that indicates the component what to render. And in this scenario, we are basically in charge of what the component is getting as an input. So it's much more flexible. And a classic example of this, let me just, can I get my water, Jean? I'm very thirsty. Thanks. Is it a cliffhanger? Like classic example and a blank screen? Okay. A classic example of this is a mouse coordinates component. What this does is basically it's a div that's just keeping track of mouse movements, storing it in the state, and then every time the state changes, it's being passed to the render function that you're seeing right here. So it's a classic example when we want to share the power of this type of tool. And the usage is also very simple. You basically use the mouse, give it a render function, and then you receive an X and Y, and you do whatever you want with it. So again, it's very flexible, and it allows for very much powerful solutions. And there are a lot of libraries using this pattern, right? React Router also uses it, React Motion, React Functions, which is also a cool library. And there's a full list at this awesome React Render Props repository that keeps growing. And that's why, if birds do it, bees do it, even educated please do it. So let's write components, right? So I want to talk about a bit about the 8 bars a week. 8 bars a week, it's a small project, pet project that I've been working on the last couple of weeks. That's, I describe it as an online journal of beat snippets, most of them 8 bar long, as a way to document my adventures in Audioland. And I want to show you, because I think this might relate with some of these patterns. Yeah, that's the name of the site, and this is nothing fancy. It's just a simple playlist that I can select tracks to listen to, and these are like 10, 20-second tracks that basically keep looping, and I can transition between them, apply some effects to it, and okay, but you get the point. So this is 8 bars a week. So back to the presentation. Okay, let me just say that 8 bars a week uses Rebase for styling, React Anim for animations, and the Web Audio API for playing sounds and applying some effects to them. And I thought that this might be a cool use case to show some of these concepts applied on a real project instead of just showing mouse coordinates and something very abstract. So as an introduction, the first step when when using the Web Audio API is to create a web audio context, and this only can exist once per application. And so basically all the nodes that we want to create and to connect and every type of interaction with the audio context is being done through this instance. So basically we have to create this singleton, and we want to share it across the app. So this directly relates to the context provider that we've been talking about. Context provider in this scenario is, you're looking really at the code of my website, a simpler version, but it's the gist of it. So it's the audio context provider basically creates the audio context and just gives it as a context to the application that's being wrapped. And I thought, okay, so this is one part, and the other part will be that all the components that need to access this audio context instance, they should use the with audio context HOC. So the with audio context HOC, again, is just receiving that audio context in the context, which is two contexts at once, but okay, and injecting it as a prop in the wrapped component. Simple, yeah? So, in order to finish, and let me just check my time. Okay. Okay, the progress bar component, for example, it's a more visual component that I want to show you guys. So, as you may notice, we have this player, we have the track name, and we have the slider that keeps growing and keeps looping every time the loop ends. And in this scenario, I used render props to abstract some domain-specific problems. Okay, so the scenario is the following. So each track has the loop property on, because they are like 15 seconds short, and I have to keep looping them. And the progress depends on the current playtime. And the current playtime itself, it's not accessible, so the web audio context doesn't offer the current playtime of the track, only a global playtime. So I have to make a more complicated logic to keep reading that property from the context. So I decided to abstract that. So I developed a component that's responsible for reading the current time from the other context. And this component basically just passes the current audio time as a parameter of the render function. And of course, uses itself the with audio context HOC. So it's very funny to see how these patterns start to play with each other, and they fit in very well. So the progress bar itself becomes simpler. I'm just calling the current audio time component that gives me the current time. I'm calculating the value of the progress with this simple formula, and then I'm passing it the value as the value of this progress element, which is nothing more than a progress tag styled with the styled components library. So there's no business logic, or at least domain-specific logic that I have to tackle with. It's being done on an upper level. Cool, right? Please say so. Okay. So to sum it up, in terms of HOCs, in pros and cons, the HOCs, they are composable if we are using, for example, the Redux's compose method. They allow for code reuse and also for a divide and conquer approach in order to abstract some complexity. And most importantly, and I think this is the bigger strength, is that they enable the access the data from any lifecycle method. On the downside, they're basically creating some indirection, some name collision. They're adding a new component to the DOM tree. Every time we are wrapping a new component, we are adding a new one. And we have to not forget to hoist static methods of the wrapped components, or else they'll be lost along the way. Finally, the internal state, any internal state changes basically causes a re-render of the whole component. So this may lead to some performance issues. So, in my opinion, we should use them when we want to access lifecycle hooks of the wrapped component. If we need to do some logic on the did mount or will unmount lifecycle method, and basically where static composition is enough. So the with audio context, in my opinion, it's very simple, and I won't be using any type of component that deals with audio without it. So it's easier for me to export default and just call it right there. Also, for example, with mobile detection, sometimes we may deal with libraries that allow us to detect if the user is using a mobile device or not, and this type of HOC just gives us as a prop, and it's more handy instead of just using a render props pattern. The skip server-side rendering, sometimes we're using technologies that aren't available on the server, and we are rendering the React on the server. So in those cases, we have to check if the window is defined or not. And it's not hard to do it, but it's a pain in the ass to always keep doing it. So it's good to have these HOCs that are like tools in our toolkit. So in the render props part, we have no indirection or name collisions because we're in charge of what we're passing. They're also composable if we use the React Composer library, and they're dynamically composable. So we can decide at runtime which render props we want to use, what parameters do they accept, so they're more powerful in that way. Okay. And finally, when re-rendering, only what's passed into the function is actually executed. So this may be some advantage in certain scenarios. Again, on the downside, they increase the indentation of the file. Sometimes, in my opinion, they are a bit harder to read. We can refactor it, but it's a bit hard. And they're attached to the render function scope, so we cannot access any type of lifecycle hooks, and that might be a deal breaker in some use cases. So when should we use them? Okay, for me, to define components following the container/presentational pattern that João was talking about earlier. When the dynamic composition is fundamental in the solution, and fundamentally when publishing a multi-purpose library. So this is very handy if you, for example, want to publish to NPM a mouse coordinates package, or a fetch data / data provider pattern, or even a page visibility. I created this simple library just to inform me if the page is visible or not, and use the render props function to react accordingly. Or the Sentinel, which is also a library very useful to pull data from. So there are lots of use cases, and let me just, before I end the talk, let me just give you a small warning. It's that in the next version of React, the context API was updated. Nothing major, but basically we're now using we have the create context method that returns us a provider and a consumer, which are basically the same concepts that we talked about in the beginning of the talk, but it's a new API, so it's a small change. Okay, so lastly, I'm going to tell you about audio signal flow. Audio signal flow. So audio signal flow, and bear with me, it will make sense in the next slide. It's the path an audio signal takes from the source to the output. Can you see it? I'm gonna try to. Okay, so basically when you're connecting audio devices, normally what you do is you connect the line out of one device to the line in of the second device, and then the line out of the second device into the line in of the third device, and so on. So it's very similar. So why I'm telling you about this? It's because I thought, okay, basically an audio device, it kind of reflects what the function, a render props function is doing. It's basically cascading properties down. So what I'm doing right now is I'm cascading, I'm making an audio signal flow, and I'm making the props flow. Okay, this application isn't in React, so that's why I'm using it in the slide itself. So I imagine, okay, there's an audio device component. I can make an audio device component that basically passes the line out to the render prop. It will receive it somehow, and guess what? It will be a render prop, and then it can render the current state of itself, which would be the line out. And this component would use with audio HOC that I was talking about earlier. Basically, I just copied the code from my website. So we're looking at the code, which is highlighted. I don't know if you see it. Yeah, I'm highlighting the code of the current slide that we're looking at. We are looking at the audio context provider. That's basically creating the web audio context instance. We have an audio source component, which is using the mic as the line in, and then it is connecting to the audio analyzer, passing it the line into it, which connects to the audio visualizer. And this is it. It's audio signal flow with the render props. And I'm finished. So thank you for coming.